Hello guys and welcome to today's video, and today we're going to be talking about computer programming. So what is computer programming? Computer programming is a process for telling computer what to do. So we're telling the computer to do something and the computer follows our instructions. But the computer can only understand one language, and that language is called code, and we'll get to that later. So codes are simple instructions which computers read and follow. For example, the most basic code is print hello world. And you can see in the picture right here, once you typed in the code, the computer processed it and then turned it back into a visual. As you can see, it printed hello world, or the computer typed it. So this is an example of a code, and this is what programming really is. It's designing and telling the computer what to do. Now, programmers are people who work for these codes. They basically create instructions for computers to work. So they are the ones who work with the programs and with the codes. So where is programming really used? So the codes computer programmers make are used in our functioning devices. Programming allows devices such as cell phones, TVs, and laptops to work. It is also used to build applications within the devices such as games, social medias, and browsing apps. Let's watch this quick video which explains what exactly a program actually is.
Hi, welcome to programming. If you've never learned to program before, you might be wondering what programming actually is. Well, when we write a program, we're giving the computer a series of commands that kind of look like a weird form of English. You can think of a computer as a very obedient dog, listening to your every command and doing whatever you tell it to do. So what's so cool about programming? Well, it really depends on what you think is cool. Because as it turns out, you can use programming for almost everything. Programs control robots that can take care of patients. And my favorite, robots that can roam around Mars and look for water on the surface. Programs help self-driving cars know which way to turn, which is pretty important. Programs help doctors cure diseases by processing huge amounts of medical data. Programs can be really fun games, like Doodle Jump, Angry Birds, Minecraft. Programs make it possible for Pixar to put out their awesome 3D animated movies, and for movies like Harry Potter to have such cool special effects. What's your favorite movie? I bet that a computer helped make it somehow. Programs are behind the websites and the apps that you use every day, all the time, like Google Maps and Wikipedia and YouTube. And of course, where you are now, Khan Academy. Here on Khan Academy.
Okay, so she basically introduced us about where programming actually is used in our daily lives. And you can see that those usages are all similar to what we studied last time, which is technology. And remember, in technology that we use it in health, we use it in robots, AIs. It's the same with programming. But the process of programming is kind of giving the instructions for what the device to do. The technology itself is the device, and the programming part is designing what to do with it. So, smart and stupid. So computers are both very smart and very stupid. So what I mean by that is that computers can only process simple tasks, such as print code, like I mentioned before, but they can process billions of those codes in a second. So it's stupid that they can only understand simple languages, but they're super smart that they can process these billions in a second. It's quite amazing. So now getting deeper into what coding is. So again, codes are simple instructions which computers read and follow. So the most basic instructions to the computers are only made out of zeros and ones, and they are called binary codes. So this is what the actual computer processes and then makes it into their own language, and then transmit that data into what is presented. For example, I'm using a monitor, so what is being presented in my monitor is all due to codes. and they only take it in by binary codes, which is the most simple code there is, made out of zeros and ones. So these programming languages are what really helps us connect the line between a binary code and English language. So programming languages are English versions of these binary codes, as you can type instructions in English. So there are different applications you may use, such as Python, TypeScript, C++, JavaScript, and way more. And these are different types of languages where you would really so these programming languages is where you can type in English and how that English written code can be transmitted into the computer, and then the computer can process it by binary code and then so on. The codes in programming language look something like this. You can see in the picture here. Constant, local, global this, dot navigator, dot language. And remember that codes all differ depending on what programming languages you use. So let's say you use Python, that means it'll be different from when you would use a JavaScript and when you would use a TypeScript. They're all different. So now, how to actually create a code. So open up any programming language, for example JavaScript, and start by inserting any command such as var, print, math, pull, debug, value of, and edit however you would like. Note that creating code is a complicated subject, and we will get into more detail in another lecture, but for now, we will watch a video on coding.
Listen, there's a good chance somebody's trying to hack your website right now. You gotta make...
Writing code is writing a precise set of instructions a computer or device can understand. It's explaining exactly what you want your computer to do at any given moment. Computers need to know exactly how to react to things, like the clicking of a mouse or the pushing of a button. And whatever happens, ultimately is happening because of lines of code written by a human programmer. Just about anything with a plug or battery uses code. It's keeping our airplanes in the air. It's allowing you to swipe a credit card. And the computer doesn't know what to do in any given situation. It has to be taught everything. So you can think of a computer programmer explaining to a computer what we want it to do as like trying to give someone directions for how to drive somewhere when they don't even know what a car is. So you can see what kind of complications you'd run into. You'd have to not only tell them how to get to where they're going, but you'd also have to give them contingency plans for things like what if there's a traffic jam, or what if a truck breaks down in the turn lane, and you'd even need to explain precisely how the steering wheel or gas pedal works. So that's kind of like a computer programmer writing code for a computer. They have to basically teach it everything every time. To understand that communication and how this process even started, you have to go back to the Industrial Revolution, where the first computer program was invented in 1801 by a guy named Joseph Jacquard. He developed a system of weaving instructions, or code, for his sewing looms that could be stored on cards with holes. And there was a mechanism that would go along the card and try to push a pin through. And so either the pin would go through or it wouldn't. It's binary. It's either it does or it doesn't. It's a 1 or it's a 0. And so if the pin goes through the hole, it would allow a rod attached to it to lift, which lifts the string and lifts the associated thread. And if the pin does not go through a hole, the pin doesn't move and the thread doesn't move. So essentially, the card would hold a preset pattern that is read by the loom and serves as a guide, giving the direction to the threads one at a time. And with this contraption, you can create very fancy pieces of weaving. And this idea of there being recorded information read by a machine was quickly borrowed to be applied to mathematical computation. Charles Babbage invented the analytical engine in 1837, and it was basically a calculating machine. Eventually, transistors are invented, which replace punch cards as a way of transferring data, and nowadays we use computers that have billions and billions of transistors, but still carrying that same basic idea of on and off to carry data. As a way of harnessing these various combinations of transistors, we use code. Computer programmers use different languages, whether it's Python for gaming, Java for desktop applications, or Objective-C for an iPhone app. computer program is only a text file following those rules, and it's eventually translated into something the computer can understand. Just like the pins on Jacquard's loom, a computer can only understand two things. Think of 1 and 0 as the alphabet of a computer. It's like, if you look at the alphabet of the English language, there's only 26 letters, and by themselves, they're meaningless. But when you combine them into different ways, you get the Great Gatsby, or Romeo and Juliet. In the same way, billions of different combinations of 1s and 0s have the potential to give us Microsoft Word or iTunes. And the process goes like this. On the top level, you have a human writing code for a specific computer language, and after this, the code is translated or compiled into a low-level language by a tool called a compiler. And finally, the code is translated into binary or machine language by an assembler. So because we have a way of translating human orders in the form of code into 1s and 0s that a computer can understand, after that, it's really just a matter of what you want the computer to do. And it's like being a chef writing a recipe. Because both chefs writing recipes and computer programmers writing code both have the ability to create something awesome using the resources and tools available.
Yeah, that video quickly described what code actually is and how there are binary codes, and starting from the revolution that code that comes from is all connected. So what that means is that what we write in English in code gets all transmitted into binary codes and into the computer where it's understood, and then it gives off a certain results. And now I would like you guys to try this code yourself, and you can actually try it in Notepad, which is quite interesting. So I'll actually show you guys right now. If you type in Notepad and then open it up, you would have a new Notepad. And now, let me just try to make it small and then make the letters quite big. Alright. Okay. So I want you guys to first type in @echo off. This will create any other echoes or repetitions to turn off for this code. So I would like you guys to maybe set the color. I'll set mine to 0A, which I believe is green. So you can change it to A, B, C, D, E, or any of them. I just chose A because it's just a random color. And then I want you guys to type, let's see, echo hello world. This is a simple one. Okay. So this would print the word echo. The phrase hello world. And remember that this notepad uses this echo function. And remember that in all different coding languages, the word echo can differ. So it can be print, it can be something else. But in Notepad, they use the word echo. So remember that they are all different. And yeah, it's gonna be differ by the programming language you use. And then I would say maybe echo again, and then hello world again. And then, let's see. And then we have to pause it with a semicolon. Semicolon basically ends the code for Notepad. So this is your code. You have it ready. Now, how would you present this? You would first click Files, and then Save As. Save as anything to download. Type in, let's see, test. Say test0.bat. Remember that BAT file is very important, and you have to save it into .bat file, or your file will open in the command prompt. So what I mean by that is, once you save it as BAT file, and then actually open it up using File Explorer, you should have test0 right here. If you double click, it opens up. And what does it say? Hello world again. Press any key to continue. If you press any key, then it closes. this is a very simple code that you guys just created by just using Notepad, which is very interesting. You guys should have Notepad installed, so you can just type in Notepad on the search bar of Windows and you should have it open. Now I want you guys to maybe try different categories this time. So I will label this main class, and this will be the first class of this code. And let's say I want to use a different class, and you would say another class, something like that. Echo, here is another class. Let's see, something like that. Alright, here is another class. And then, of course, you have to pause at the end with semicolon and closes it. Now, remember that we have to save it. Save. And then if we open back up, now what does it say? Hello, this is another class. But see how this says here is another class in the same class. Now how would you fix that? I would actually leave that up to you actually. And there is actually a multiple way to fix the different classes. But I want you guys to maybe test it out on your own. So I'll leave that up to you. And let's try the next picture here. Okay, let's try this one on the right. Let's erase everything. And now start with add echo off again. And let's say in your main class, echo, what is your name? With a colon. And then this code will make you type and actually interact with the command prompt that opens. So what I mean by that is if you type in the code set/p name equal, then you would put in echo the name you enter is, do you wish to continue? And then let's just pause it there. So I want you guys to maybe look at the code and identify it. So by just the code itself, it does not mean anything. It looks pretty weird, right? Add echo off, main class, echo what is your name, set/p name equals. It's very confusing, but if we actually present this, we would get a pretty solid result. Just remember that echo is what is saying, what is being printed out, and set/p is what you can interact and type, and echo again, and then %name %. This %, what this means is that whatever you entered here will be presented in the sentence here. Now let's see it. Let's click save, and then open it up again. What is your name? I type in mine, Javen Shin. Enter. The name you entered is Javen Shin. Do you wish to continue? I paused it here, so it should close. Yep. So now, you can see that this is an example of a very basic code, but you can see how this is really useful, and you can just see that I was able to type and interact with the code myself, with the code that I made. And it is really interesting to see how that small thing can build up to even big things like Google I'm using right now, or any other softwares that are being developed by programmers. Remember that every device and every functioning device, and even applications, games, videos, they're all made by programmers, and you need programming to make a device work. Programming is basically telling your device what to do with the code, like I typed here. And remember, a code is a language which a computer can understand. So again, programming is what we're telling the computer what to do. The code is the language the computer understands it. And then the programmers make all these different games on your devices and videos, softwares, everything's made by programmers, by programming. You can see that everything is connected. And again, in Notepad, you guys just created your own code, so you can be proud of that and present it with a bat file. And yeah, thank you for watching, and I really hope you enjoyed it, and I really hope you learned something about programming, and I'll see you guys in next week, and bye.